Hello Internet, my name is Quinn and this is Blondihacks. I'm working on my locomotive this week and I'm going to make the handrails that go down the sides of the boiler for the crew to hang on to when they're scrambling around on the machine. This was before the Depression, the heyday of this locomotive, so human life wasn't yet fully expendable, and well, if too many people are maimed by the machinery, then it's not good for business, so alright, we'll give them a handrail. Let's go. Up here along the side of the boiler and the smoke box, you can see there's holes there and in the smoke box as well, and that's where the handrail mounts all along there. So we've been preparing for this for literally years. We put those threaded bosses in the boiler way back in the day, and they finally get their moment to shine. The handrail's held in place with some little stanchions, which you will recognize as being very similar to the ones I did for the smoke box. So, thinking I'm pretty clever, planning ahead for this moment, I saved the fixtures for making those stanchions. This should make these ones a little bit quicker. I have a drawer here where I keep all of the bits related to this project. Whenever a project is literally years in length like this, it's a good idea, I find, to have a compartment, a bin, a drawer, something to keep everything together. And some of my fixtures are labeled, very handy, but unfortunately I only came up with that idea late in the game, so I have a whole lot of fixtures in here that I honestly have no idea what they're for. They look very important, they're all nicely made, and I don't know what they do. So I guess I'll have to rewatch all my old videos at some point and try to watch for where these fixtures were used. So I know there was 2 involved in these stanchions. Unfortunately, it looks like I only saved 1, but that's okay, that'll save us a lot of effort nonetheless. I need 6 of these stanchions, and they are all stainless. I'm going to use this piece of mystery stainless. It's unfortunately not labeled for the exact alloy. That happens sometimes because I get materials from viewers sometimes, or I have some materials left over from my very early days when I wasn't as good about labeling stuff as I am nowadays. I didn't know the importance of labeling alloys sometimes, so I'm pretty sure it is 304 based on how it's turning. It's not super easy to machine, so it's not 303, and it doesn't leave beautiful finishes right off the tool, so I know it's not 316, so probably 304. Nevertheless, we're going to start by facing off the end as a tradition, and then I'm going to touch off on the end and set my DRO, and as I'm doing all of these initial steps on the first part, I'm taking notes about all of the different DRO positions and so on that are being used, the amount of stick out I started with and so on, because of course I'm going to be repeating all of these steps 6 times, well 5 times I guess, so I want to make that as efficient as possible. I'm in mass production mode at this point. On this first part, I'm also going a little bit slower and double checking with a micrometer the dimensions that my DRO is reporting and so on, making sure everything's properly calibrated, because once I've done this first part, then I can make the other 5 running to the numbers on the DRO and not have to check anything. So that eliminates a whole lot of measuring and double checking and so on. Regular viewers will know I recently upgraded the DRO scales on this lathe, and it's repeating really, really well now, so I can really trust it for repeating parts like this. I'm going to start by turning down a thin shoulder on the end of the part. This is a threaded stem that all of the stanchions have. That's how they attach to the locomotive, of course. Break all those edges, then I'm going to flip around to my tailstock, and I'm going to get my tailstock die holder installed because we're going to be putting the mounting thread on those. And this order of operations is largely the same as you saw me do last time for the smokebox handrail. I've refined it a little bit, but it's carefully thought out to do these parts in batches for each step and minimize the number of setups, and I'm kind of running the parts through each setup and each fixture just like you would in a production shop, basically, because I have a lot of them to make. This tailstock die holder, if you're curious, is a stem with an interchangeable barrel for different die sizes, and then a shared Tommy bar among all the barrels. I have a video on making this setup if you're interested. It's worked really well for me for many, many years. For these really tiny threads, you can just use your fingers. You don't even need the Tommy bar. Some people like to knurl their tailstock die holders. Personally, I don't. I don't actually like knurling that much if I don't have to use it. And really, there's only 2 choices I find. Either ones that are small enough like this that you can do with your fingertips, or ones that are much tougher and you need the Tommy bar anyway. Then I chamfer that after the threading, because the threading operation always pushes a bunch of material off the end of the thread. Lots of folks say to chamfer before you cut the thread, but I find that just means I have to chamfer it twice, because you always have to chamfer again after the threading anyway, so that's how I do it. But, you know, you do you. Next, I'm going to turn down the rest of the available stock to the largest diameter of the final part. I didn't do this earlier because as I work, I'm working in sections moving towards the chuck, because as you can see, I have a fair bit of stick out here, and stainless is very tough cutting stuff. So I want to keep as much rigidity in the setup as I can, and you do that by keeping the material right behind you as thick as possible for as long as possible. So by working in little sections, you can often get away with more stick out than you otherwise might. Also, this is stainless, which is very, very strong. So while it is tough cutting, it's kind of more than offset by its own internal strength, and so it can handle more stick out than something like mild steel would. And by not having tail support in here, it's saving me like 58 more steps, because I'd have to have extra material at the end and face off the center, and it's, be a lot more extra steps. So if I can get away with the stick out, I'm going to do it. And again, this is the first part, so I'm sanity checking my DRO here, making sure everything is working. Then I'll set up my parting blade and part off this first blank. This is as far as we need to go on this first setup. Parting stainless is a bit of a dangerous game, because if your speeds and feeds aren't perfect, it will work harden instantly on the end of the tool and, well, blow up your parting blade. However, this particular parting tool that I'm using here was one that was sent to me by Mark over at Winky's Workshop. He designed this. It's a spring-loaded parting blade, similar to ones that were used back in the day when lathes were less rigid, and it works really well on tough cutting materials like stainless and tool steel, so it's my go-to, and I trust it in situations like this. Now, this will be relevant, however, in the near future, so stay tuned. And Jahtzee. Now that, 5 more times. I gotta bring all of them up to this same stage. At this point, all 6 of these stanchions are identical. Now I'm gonna clean up the ends of them a little bit, which is a bit of a wasted step because everything's still in a raw, blank form. However, things need to align repeatably for a fixture that's going to be coming up in the next step. So sometimes you have to do some intermediate finishing, even though it's kind of throwaway work in a sense. At this point, I also want to do some inspection because, again, there's a fixture coming up and all of these parts have to fit correctly and the same in that fixture. So if there's any little errors in any dimensions on the parts, I need to know now. The fixture in question is the little drilling jig that you saw me pull out of that drawer. And if you remember when I made the last set of these stanchions, one of the flaws in this jig is that it didn't have a through hole for holding the parts, so they were difficult to get out of the jig when I was done. So I'm going to correct that now before continuing. I'm going to drill that all the way through so that I can push the parts through from the back. When you cross drill in a fixture, the burrs in the drilled hole lock into the fixture and it can be very difficult to get the parts out again. So there's my through hole. Now I'm going to center up on this because I need to drill a new cross hole in the jig because these stanchions come in 2 new sizes that are different from the old ones on the smoke box. And unfortunately, my fears were realized. I thought this might happen. The hole needed for the new ones is too close to the hole used for the old ones. Now these new stanchions come in a shorter version and a longer version. So the longer version is close, but it's just the hole is going to be about 5 thousandths away, and that's not enough wall thickness. It's going to break through. So I have a plan, however. I'm going to flip this so that the machined end is down on the parallels, machine the far end, clean that up. Now I've got 2 parallel ends on my fixture, and then I can flip it back around to the business end of it, and I can face this all the way down, basically as close as I can get to that fixturing set screw as I dare. And what this is going to do then is push the cross hole further away from the existing cross hole, as you'll see. Part 2 of my solution is that I'm putting an additional set screw at the other end of the fixture because for the other size that I need, I'm going to use the other end of the fixture. As you can see, shortening the first end of the fixture gave me enough distance from the other cross hole for the longer of the 2 new sizes of stanchion that I need. So that'll be our first step. I need 2 of the long ones. All this cross drilling and such has created new burrs on the inside of the holding area of the jig, and it's of course very close fitting on the parts, so I need to deburr those, and I use the drill to do that. And now I can feed the first blank into the fixture. As before with this fixture, the shoulder on the part is the reference surface, so I line that up with my scale, snug down the brass-tipped set screw which holds the part without marring it up, and then I can cross drill that all the way through. Drilling stainless, especially at small diameters, is again a little bit of a dangerous game. It's not bad in like 303 free machining stainless, but this being probably mystery 304 stainless, I'm being careful here. You want to keep your RPM a little bit on the lower side, and you want to get in steady, even pressure, and if you need to clear chips, get out again and get back in again with purpose. Don't linger, don't let the end of that drill rub, because especially with a small drill, you won't even feel it happen. If it starts rubbing at all, it'll work harden the surface, dull the drill instantly, and the part is scrap. You'll never be able to drill it after that. Tappy tap tap that part out, and look at that. Perfect cross hole in exactly the correct location. Drilling jigs are extremely satisfying to use. Now I can swap the next blank in there, line up that shoulder once again, and run that drill through again, and the second one is going to come out just as perfect. When you have multiple parts to make, a drilling jig like this saves you so much time. Now I'm going to line up on the other end, and I'm going to drill a new cross hole for the shorter of the new stanchions that I need. So using the other end of the fixture, because again, the other two holes are too close to this third one that I now need. There's 3 sizes of these stanchions. You might be tempted to try and use the other side of the fixture, but for cross-drilling round stock, you really need the entire depth of the fixture because you want somewhere for the chips to go, and there's no way to really break through the far side of the part without getting into the other half of the fixture. So don't even try doing that. Over to the lathe now, I need to recreate the other fixture that I couldn't find. You may recall, and luckily this is a very simple one. It's just a piece of scrap round bar that I'm going to face the front of, and I'm going to drill and tap a hole that's going to hold the little stems on these blanks. This won't be a super concentric work holding method because of course threads are not a good concentricity reference, but these are decorative parts, so it's fine. With a larger drill, I'm also going to put a little counter bore in there, and that's actually the most important feature of this fixture, arguably, because these little parts have to thread in such that the shoulder seats perfectly tightly down against the face of that fixture, because that's where all the rigidity comes from. If there's any gap there at all, then it's only the thin stem holding this part, and not only will that definitely be not rigid enough, it will also probably bend that little stem. Okay, here we go. This is an order of operations that's well refined at this point because I will have made 9 of these by the time I'm done. Start by bluing up the bottom part of the blank, and using a feeler gauge against the fixture and my scribe, I mark the distance of a shoulder that gets left at the bottom. That's sort of the decorative base of the stanchion. Then I turn down the area above that to the slightly smaller diameter, which is the diameter of the ball end of the stanchion. Then I blew up the upper end so that I can use my odd leg dividers, as you can clearly see through my transparent hand, to mark the underside of the ball section. And this gives me a zone in the middle between the base and the ball to turn the tapered stem of the stanchion. I'll use the compound to turn that tapered stem. Drawing calls for a 6-degree included angle. I have a simple 3-step process for setting my compound angle. First, I set it to the included angle of 6 degrees, as specified in the drawing. Then I check it with a protractor, and then I remember that actually the markings on my compound are off-axis angle, so I set it to half the included angle, and then I check it again with a protractor, and then I remember that it actually needs to be set the other way, so I move it to 3 degrees the other way. Simple 3-step process that I do every time I set the compound angle. From here, it's just a whole bunch of turning with the compound. I actually really like turning tapers with the compound. It's weirdly satisfying. You can see I'm using a custom ground kind of hook point tool there that allows me to get in really close to the base at the bottom and the underside of what will become the rounded top part of the stanchion. Last time I did this, I had a few folks ask why not use a form tool for this. And the answer is simple. Form tools have extremely high tool pressure, like very, very high, to the point where you can really only get away with them in super easy to cut things such as brass or aluminum, Delrin, that sort of thing. Stainless is very, very tough cutting, so everything's got to be done single point, even the little taper section. The drawing gives a dimension for the small end of the taper, so I mean, just measuring with the guessometers is fine here, it doesn't have to be perfect. I'm actually leaving it a little bit oversized at this stage because I'm going to be turning the ball by filing. And I know from experience that turning the ball end of this tends to remove a little bit of material from the taper area. It's hard to avoid even with a safe edge file, so leave myself some extra material there. And then, yeah, just a whole bunch of filing. Now, this is not going to end up with a perfect sphere, and that's really not my goal. My goal is to make all of them look the same rather than to achieve a specific shape. In fact, I don't actually want them to be a sphere because the cross hole is quite large, and I think if you achieved a perfect sphere, there wouldn't really be much material left, and I wouldn't be confident in the strength of the parts. My final step is to use a round-nosed tool to make the little fillet at the base between the taper where it joins up with the wider base, make it look nice. It's a small detail, but it is noticeable once you've seen it. Finally, I hit everything with some 320 grit emery. As I said, this is mystery stainless, and the surface finish I'm getting off the tool is definitely not going to win any awards, although those surface finish awards are all political anyway, but some quality time with 320 hides all the sins. Since these are kind of attractive detail parts, I'm going to take them one step further. Once I've done all 6 parts to this point, I take my mandrel out of the lathe, put it in my hand drill, and I'm going to run them all over the Scotch-Brite wheel. The 320 does a nice job, but the Scotch-Brite wheel will elevate the finish just that little bit more. If there's any rogue tool marks or anything, this Scotch-Brite wheel will take them out. And the Scotch-Brite wheel is actually really aggressive. You got to be careful with it, so I'm doing a very light touch here, but it'll also help blend things together, like if you have any rogue burrs or little edges that are a little bit too sharp, transitions that are too sharp, the Scotch-Brite wheel just kind of softens everything and puts a really nice even satin finish on the parts. For parts like this, I actually prefer a satin finish, but if you wanted to, you could at this point put them on the buffing wheel and polish them really nicely, but that's not the look I'm going for. To me, freight locomotives are hard-working machines, and they should look like it. You know, a banged-up, dinged-up locomotive is an honest one, and these machines worked for a living, and I think they should look like that. They were not jewelry. They were not cars. Well, those came out great. Really happy with those. 2 of them need nuts, of course, because they go into clearance holes in the smoke box, so grab some stainless hex bar and knock out a couple of nuts. Now, things got interesting here, though. I threaded enough material for 2 of them. I got out the parting blade, as before, and, well, after you've had several years' experience with parting blades, you start to learn when they're unhappy by feel and by sound, and as soon as that parting blade touched that hex bar, I could immediately feel it was very, very unhappy. It was not going to cut. It wasn't forming a chip, I could tell. It was immediately rubbing, and it was going to start work hardening if I tried to push that. So there just isn't enough rigidity here between the width of the parting blade and the amount of stick out, and the fact that it's hex bar, which is an interrupted cut. All those factors combined meant the parting blade was just not going to do it. So I'll get that block of wood down there, and let's fret saw the first one off. Fret sawing 304 stainless is not a lot of fun, but it is a lot more fun than blowing up parting blades. Hey Quinn, what's the block of wood for? Any other questions? Yes, that is very hot. No more questions. For the second one, I was closer to the chuck now, so I thought I might get away with the parting blade this time, and indeed I did. That little bit of extra rigidity by being closer to the chuck was all it needed. I'll make the handrail bars themselves now. These are very simply some cut lengths of round bar, and I'll use the belt sander and Scotch-Brite wheel to put some hemispherical ends on it. Nothing precision here, just trying to make them look nice. All right, we should have all the parts needed to get this installed on the locomotive, so let's give it a try. I'll put the clearance ones on the smoke box first. Now maybe you can see why 2 of them are longer, as I said earlier, and that's to take up the difference between the smoke box and the thickness of the boiler jacket. The smoke box is a little bit smaller diameter, and of course you want the bar to be running straight all the way down the length. The other 4 get threaded directly into the boiler, and this is where I realized, oh crap. The holes on these have to be timed correctly because they're being threaded in. Now, amazingly, 3 of the 4 of these lined up perfectly just by luck. However, 1 of them did not. On this back corner right here, no matter what I did, this came out just about 90 degrees off, which is the worst case scenario. I actually tried all 4 stanchions in that hole to see if one of the other ones happened to be clocked better by chance, but nope. What I should have done is threaded them all into their respective holes before drilling and then mark the orientation of the drilled hole. If you want to see what that looks like when done correctly, check out when I made the cylinder drain valves, which also have to be accurately clocked. I loosened it a bit to get it aligned, and I decided, well, I'll feed the bar in here, and maybe being the tiniest bit loose on that one won't hurt anything, because it's just one of many stanchions holding this bar in place. The bar is a friction fit inside these, so it's actually a bit of a job to get it fed through there, but that's a good thing. That means it won't rattle or slide out through vibration or anything. There's no fasteners holding it in place, just friction. But I got that slid in there, and I mean, it looks fantastic, but if you watch my left hand while I'm lining things up, you'll see that end stanchion moving all over the place. You can see it wiggling, so it's definitely not tight enough, and I was going to have to do something to fix that. 3 out of those 4 being correctly timed by chance is actually not as unlikely as it might sound, because these are very fine pitch thread, and the clocking only has to be right to like plus or minus 20 degrees, something like that. And with a fine pitch thread, you can snug them down a little bit more or make them a tiny bit looser to get the holes to line up, and the bolt will still be tight enough to hold well. Because that one is off by exactly 90 degrees though, it's worst case scenario, I'm going to have to fix it. There's 2 ways to fix clocking on a component. I can either remove material from the underside of the flange so it threads in a tiny bit further and lines up the holes. I did actually try that, but it was going to have to be done with a safe edge needle file so I don't damage the threads. And needle filing 304 stainless is brutal. It's so slow. I actually spent about 20 minutes doing it and got nowhere, so that wasn't going to work. The other way to fix a problem like this is to shim the thread, thus causing it to be slightly less threaded into the hole, if you will, and lining up the holes that way. You can actually calculate how much of a shim you need, or how much material you have to remove, that is, with the pitch of the thread. So these are a 3/48 thread. That's 48 threads per inch, so invert that, and that gives us 21 thousandths per thread. We need 90 degrees, so that's a quarter of 1 thread. So divide that by 4, you get basically 5 thousandths of shim, or 5 thousandths of filing that we need to do. If you're doing this in metric, it's even a little bit easier because, of course, metric specifies the thread pitch and not the density, so simply divide the thread pitch by 4. Because I only needed 5 thousandths, the easiest thing to do was take a little piece of 5 thou shim stock, which is so thin you can cut it with scissors. It's not very good for the scissors, but scissors are easy to sharpen. And I made a tiny little washer, if you like, out of this shim stock. And it's a little bit ugly looking there, but once it's threaded in to the boiler, you can't actually see it. So really, it's fine. There it is, threaded in. You never know it was there. Just another shim among many shims on every locomotive in the world. That worked perfectly though. That stanchion is tight. Both handrails are now rock solid. The little crew is going to be very, very safe hanging off of there right up until the depression kills them. It's going to be amazing. Well, I hope you enjoyed watching me make those. It's amazing how much effort these detail parts are, but they really do make the difference. Every time you add something like this, it elevates the whole machine so, so much. And well, I'm very, very pleased with how those came out. Well, thank you so much for watching. Thanks to my patrons for making all of this content happen every single time, and I will see you next time.